trig, the initial side, of the angle lies on the positive x-axis. So it starts kind of like this arrow here, and then it rotates. It rotates until it gets to the terminal side. So it starts on the initial side. So we have an initial side, and we have a terminal side. We rotate counterclockwise for positive, and we rotate clockwise for negative. When you practice for a while, it's not bad. It's just basically we have, I don't even care. If you don't remember the name initial and terminal, just know that we have an angle. And these angles always start right here, pointing at that x-axis in that direction. Always. It's that ray. That's where we start. We're just asking, how far did we twist it? How far does that angle open up? So I'm asking for this in degrees. Now, do we have enough information to give us an exact value there? No. So we're going to approximate that. What's a good approximate for that? Don't tell me it's 80, because that doesn't make any sense. 120. That's a good. That's what I actually have in my notes. So we're going to say that's 120 degrees. Why is it positive? Because it's going counterclockwise. It feels weird. It feels like clockwise should be positive, because we always say clockwise, but it's counterclockwise. So that's going to be 120 degrees. Now our next one. I'm going to say we went this direction. What's the first thing I know about that angle? It's going to be negative. So it's going to be negative something. Now, we do have enough information now. Based upon the first one, I'm saying the first one was 120 degrees. What's the next one then? So you can't guess. It has to be an exact value. Yeah. It'd be negative 240. How'd you get negative 240? It's the opposite of 120 because there's 360 degrees in a circle. So if I go negative 240, I'm in the same place as a positive 120. Does that make sense-ish? Okay. Then we'll keep plugging through. Now, when you're dealing with angles, sometimes it'll go all the way around. So sometimes we'll do something like this. And we'll do that. I don't like that. Do you like Ferris wheels? No? Oh, okay. What's the measure here then? 480? You sure? I got to write it down. I can't erase it once I write it. How do we get 480? 360 plus 120. Thank you. 360 plus 120 is our 480. Okay. We know degrees, right? I hope. Yes. Now we did all the major things, positive, negative, multiple direction. Now we're going to find the terminal side of angles lie in which one of the four quadrants. Let's rehash our quadrants. Quadrant, 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 quadrant. I did them in order. It helps you out a little bit, right? All right, yeah. So we need to know that's quadrant 1. That's quadrant 2. This is quadrant 3. And we have a quadrant 4. I'm going to go ahead and put the key degrees on here because it's going to help with radians. I'm going to go ahead and say, okay, this is 0 degrees. This would be 90 degrees. This would be 180 degrees. And this would be 270. Do we need to do that every single time there's degrees? Probably not. Just get know what those are. So we're doing a positive 140 degrees. That's between 90 and 180, I assume. I'm not looking for perfection. I'm just looking for, oh, okay, it's going to be somewhere in this quadrant. I have no numbers. I just need a line in that quadrant, and that is quadrant 2. That's easy enough. Negative 140. Sometimes it can be helpful to draw these exact same 90, but draw them in the opposite direction. So rather than going up to 90, I'm going to go straight down to negative 90 degrees. Then I'm going to go, oh, this would be negative 180. And this would be a negative 270. What quadrant would negative 140 be? And raise your hand. Don't just shout it out. Just make sure. Mercer. You're saying third quadrant? You agree, I would agree as well, because that line would be somewhere about there, somewhere between negative 90 and negative 180. That would be our third quadrant. When you have something big, 1,225.6. It's not that big a deal. What was that?
360.
We could divide it by 360 to see how many times. What can also help is just subtract 360 sometimes, but we're going to divide by 360 to see how many times we need to subtract. Because I don't care how many times it's spun around in a circle. I just care about what's that last turn. What's that turn that's between 0 and 360? And we'll get to that in a little bit. That's called coterminal. So all we know is this goes in the positive direction in around a few times. And he said we can use division to come up with how many rotations it has. So we can go 360. How many times does that go into 1225.6? How many times does 360 go into 1225.6? At least twice.
3 times.
3 times. Do you guys have calculators?
I lost mine.
Oh, we need a calculator.
I gotta find it. It's,
Okay.
it's somewhere around here. I gotta ask around.
What was that? 3.4 times. I really just care about the 3 point something, right? The 3 times is what I care about because let's go ahead and do the drawing. The drawing now is I go around once, twice, 3 times, and now it goes a little bit before that, 0.4. But the easy way to do that is just take that 1225.6 and subtract either 360 3 times or subtract 3 times 360. What does that come up to?
34.0.
Why did I get 2 answers? 145. Uh-oh. Uh-oh.
I did it wrong.
That's okay. I got 145.6. That's what we said, right? Okay.
So it's in the second one.
Yeah, so we'll do that 1225.6. We will subtract, usually if I'm on my calculator, I'll just subtract 360 3 times really quick, but we could do minus 3 times 360. And that should have came out to, what did we say, 145.6. 145.6, that is in the second quadrant, right? So we end up in the second quadrant again. Here's my advice to you, especially when we get to radians. If you don't like the angle given to you, it's too big or it's too negative. Either add or subtract 360 until it's a more manageable angle. Because that will be what we're going to get to right now called a coterminal angle. That will be a coterminal angle. So that's the next thing we're going to talk about. Coterminal angles are angles in standard position that have the same initial side and the same terminal side. In my notes, what I did is I actually pointed coterminal up to the very first 3 angles we did. I can't really do that on my slides because those first 3 angles are all coterminal. So let's look at those 3. So I'd have an arrow going all the way up to these first 3. All 3 of these angles are coterminal. If I did not draw these arrows in here, you would say they're the exact same angle. They aren't the same angle because I brought up the fact about a Ferris wheel. If your Ferris wheel doesn't turn, you technically went the same way as going around 4 times, but you're probably not going to be happy if it doesn't go around. So the angles are not the same, they just end in the same place. So we can get like quadrants, and eventually we're going to get our sine and cosine from that fact. So those are coterminal angles. Does that ring a bell? So basically, you just spin and you end up in the same place. I'm coterminal. I spin this way, I face this way, I'm coterminal. And then we have a fancy formula for it. I usually don't use the formula. It's just much easier to add or subtract 360, but I need to show you the formula. The formula goes something like this. The measure of angle B, I don't want that one, needs to equal the measure of angle A. Let's go alpha. Plus some rotations. They have to equal the same, except for the only difference is I might add 360 or subtract 360 over and over. So that's plus K times 360 degrees. where k has to be an integer. What I mean by has to be an integer, it has to be full terms. It has to be a complete 360 turn, either, it could be a whole bunch of times. It could be 5 times, and it's still coterminal as long as it's full 360 degree turn. I almost fell on that one. All right. I guess an easier way to look at that, I did put a little note after this. I said that's the same thing as just taking angle B or beta has to equal the angle alpha plus or minus 360 over and over and over. Plus minus 360. And it goes on and on and on. Where does subtraction come from in the equation? It could go in the negative. So our k would be negative. Can an integer be negative? Yeah. It just can't have a decimal after it. So it's already built into it because k can be positive or negative. If you want to be in a negative direction, you just subtract. I do want to point something out with this equation. Alpha and beta are made up angles. You do not, so if you look here on other problems, I might say beta equals this and alpha. It doesn't matter, you can flip these around. No matter which angle you put here, you'll get the same answer. Either it is or it doesn't work. So don't go, Mr. Pabian, which one's my alpha and which one's my beta angle? I don't care. It doesn't matter which one you put in there. If I ask you are 12, 25, and 45 degrees coterminal, you could put the 12, 25 here or you could put it here. Doesn't matter where you put the angle as long as it comes out to an integer. Whew. All right, find 2 positive and 2 negative angles that are coterminal with negative 50. So we just go negative 50 and it says 2 positive and 2 negative, so just add 360. Earth-shattering stuff. We're going to add 360. That will be a positive angle that ends in the same place. So that's going to be 310 degrees. How do I get another positive angle then? I add 360 again. Yeah, so we have 310. If I need another positive one, we're just going to add 360 again. And we're going to get 670. Is this coming back? Let me know if I need to slow down, because I don't know what you guys covered. I wasn't here. I didn't teach you. I need to know what was covered. Yeah.
Why do you add another 360?
Because it does say to find 2 positive angles that are coterminal with it.
Oh.
So one would be I spin once and then I spin one more time. It also asks for 2 negative angles. So what are we going to do to get to the negative angles? We're just going to subtract 360. So to get our negative ones, we're just going to take our negative 50. We'll start back at negative 50 and we will subtract 360 from that. So we should have a negative 410 degrees. And then we'll subtract 360 again. Minus 360 again. And we'll get, what, 770. It's a nice angle. Degrees, are we okay with degrees? I will note, do you remember how you have like key degrees that you have to remember? Like 30, 45, 60, and all of those. We will have to go back to those, but before we do that, we're going to get on to radians. I'm going to let you guys finish up copying down. If I ever flip the page and you're still writing, just go, Mr. Pabian, go back to the last one. I don't have a problem. Good. Cool beans. All right, one more thing. We are supposed to determine whether the angles in standard position with the given measures are coterminal. I'm going to use the equation, and then I'm going to use the way that I would probably do it with a calculator, because we all have calculators, or we will have calculators when we find our calculator. There's really easy ways to do these, and I don't think the equation is the easy way to do it. So the equation says take one of the angles. So we'll take 190. Doesn't matter which one we use. Take 190. And that has to equal negative 170 plus k times 360. All we're checking for is k an integer? If it's an integer, you added full terms to it or subtracted full terms. If it's not an integer, that means we didn't have full terms. So if I was solving for k, I'd probably add 170 to both sides first. So we're going to have, that's probably a nice thing. We got 360 equals k times 360. Divide 360 on both sides, and we should end up with k equaling 1. Your only question is 1 an integer? If it is, they're coterminal. If it's not, it is not coterminal. So 1 is an integer.
So what would be an example of
Not an integer.
this?
It'll be the next one. We'll see it. But it'll be like a decimal. If it says like 1.1, you'd say, nope, because that means it was 1.1 turns away from it. So if I have to turn and face you, I have to turn exactly 360 degrees. If it's a little bit more, they're not coterminal. So if this was like a 2, a 3, a 4, it just tells you how many rotations it was. If it was, that's fine. And if it was -2, -3, -4, that's also fine. It just means I turn the other direction. As long as it's an integer, it's coterminal. So integer leads to coterminal. I am totally cool with you doing the equation. It's just on a test. I want one less equation I have to memorize and mess up. Here's what I would do on the test. I would take one of the angles, say 190, and I will either subtract or add 360 until I get to the next angle. Either I can get to it or I can't. So if you take 190 and type in minus 360, do you get to the other angle?
Yes.
Exactly?
Yes, because it's coterminal.
Yes. So that's what I would do. If I was to do this on my own, I would just, in my calculator, do 190 minus 360 and see if it comes out to that angle, which it would.
Yeah.
Yeah.
We need to show our work with something.
I don't care. Coterminal. Here's the thing with me. So on something like this, if I know you can do it in your calculator, and you decide not to show work, and you get it right, I'm probably okay with it, because I could do it in my head on my calculator. If you get it wrong, you lose all the points. If you just go, okay, I did 190 minus 360, if you just write something in there, that's fine. Then I'll understand what you did. So on this one, if I was to use my calculator, I'd use 150 plus 360, and I'd put ... So what I want us to do right now, we'll do the easy way, or whatever way you want to do it. Do 150 and add 360 to it. Does it equal 880 if you add 360 to it?
No.
What if you add 360 again? What does it come out to?
870.
870. Does that equal 880? No. If you add 360, will it go too big then?
Yes.
Are they coterminal? No, because you can't add 360 till it gets there. So that's the way you could do it with your calculator. If you're using the equation, we would do 150 equals the other angle. Are we back? We're back. All right, so 880 plus k times 360. Here's a good example where it doesn't work, because I would... Well, we are really messing up here on my iPad. All right, so we're going to subtract 880 from both sides, which should give you a negative 730 equals k times 360. If you divide both sides by 360, you're going to get k is about negative 2.03. Check my math, anyone that has calculators. Sometimes I have it written down and it's incorrect. So just double check my math. Is negative 2.03 an integer? No. So that's an example of where it, because that's negative 2 turns plus a little bit further. So this is not coterminal. I don't care which way. I like the calculator way because it's just minus, it's just adding and subtracting. I know the formula, so I'd be okay using the formula. But if you're on a test and all of a sudden you're like, what was that coterminal formula? This is another way to do it, just adding and subtracting 360. Okay, so that's done with degrees. Now we're moving on to radians. This is really the big meat and potatoes of this. We've seen radians, correct? Am I incorrect in you've seen radians at some point? Yeah. Okay. So in degrees, 360 degrees is a circle. If I spin around fully, I spin around 360 degrees. A half circle would then be 180. Does anyone remember radians? How many radians are in one full circle? So if I spin all the way around, does anyone remember how many? What was that? 2 pi is correct. There are 2 pi radians in a circle, and that means how many in half a circle? 1 pi. These are kind of our conversion things, 2 pi and pi. We need to keep those in check. Now, real quick, we've already covered radians. I'm going to go over it really, really quick. Basically, a radian is, if you find the radius and map it on the circle, how far you turn is 1 radian. It just so happens that if you have 2 pi of said radians, you actually get all the way around the circle. So that's how radians work. I like radians better than degrees because I can describe how to get there, where a degree is a degree is this far? I don't know. So radians, we can give a little bit of definition of it. And it actually helps with the unit circle. Now, when we convert between radians and degrees, we're going to use the fact that pi and 180 are the exact same measure. They're both half a circle. So when I multiply by pi over 180 or 180 over pi, I'm really multiplying by 1. We're allowed to multiply by 1. So this is basically unit conversions. The way I like to look at it, for people that are confused about unit conversions, if you have 12 inches in 1 foot, you would use 12 over 1 to convert from like inches to feet. These are just conversions. You just got to remember pi and 180. And one direction has a nice shortcut. Not this direction, but the next one will. So we have pi over 180. Did I miss anything? Yeah. I did want to put pi over 180 will get you degrees to radians. And 180 over pi will get you from radians to degrees. Here's my hint in when you're converting. Whatever's on top is going to be what you end with. So if you have pi on top, you're going to end with radians. If you have degrees on top, you're going to end up with degrees at the end. The other one's going to cancel out. All right, so we're going to go ahead and we're going to convert to radians. Leave your answers in terms of pi. So if I have 540 degrees, you're right. We're going to go pi. Pi over what? Not 540.
Oh, times 180.
180. We're going to put 180. We're going to multiply. We're going to use unit conversions. Now, like I said, how I remember it, I did say whatever's on top you're going to end with. So if I have pi on top, we're going to end with radians. Here's actually how my brain functions in this. I have degrees. I want to get degrees, so I'll put it on the bottom. But it'll always be pi and 180 every single time. Because what's going to happen, we're using multiplication. So our degrees are actually going to cancel out. We no longer have degrees. We're just left with pi radians. Most of the time we don't write radians after. If you want to, you can. You can put rad after it. But I just leave it as pi. So we have pi radians, 540 divided by 180. What would this be in radians? Does that go in evenly? No. Remember, you got calculators.
Yeah.
It goes in 3 times. It does go in evenly. 540 divided by 180 should equal 3. So we're going to end up with 3 pi. Here's my advice if I'm unsure. 540, is that further than 1 full rotation? Is it 2 full rotations? No. So it's more than 1. 3 pi is more than 1. It's actually 1 full rotation and a half. That's the nice thing about radians is I can see it a little quicker. I can see 1 full rotation is 2 pi plus another pi. It's 1.5 rotations. All right, our next one, we have negative 270. Does negative 270 change how I do this because it's negative? No. What am I going to multiply it by?
Same.
I'm going to multiply it by the same. And what is the same? Pi over 180. Always pi over 180 because then our degrees cancel out. This definitely doesn't go in evenly, but we could. It simplifies, right? I don't have this. Yeah, it should be like 1.5 or a negative 3 over 2, negative 3 pi over 2, or a negative 1.5 pi would be fine. So 270 over 180 can simplify to 3 over 2.
So not a whole counterclockwise turn.
Right, because it has to be 2 pi would go all the way around, right?
Yeah.
So it's actually kind of a half and a quarter.
Yeah.
Yeah. Well,
Counterclockwise, right?
but counterclockwise, or it'll actually be clockwise.
Oh, clockwise.
Yeah.
Yeah.
You knew what direction it was supposed to. Like I said, whenever I think clockwise and counterclockwise, it confuses me. I'm just going to go down this direction. I'm going to go up this direction. Because positive feels like you should just say clockwise. For whatever reason, it isn't. All right, so that's how I go from degrees to radians. Now, to go from, do I not? Oh, I do have them here. I'm going to show you the long way. There's a quick way to do this sometimes. So we have 14 pi over 9. Now, here's my advice. Degrees do not have pi in the answers. Those are your radians. So here's what I'm going to immediately do. I'm on the test and I kind of forgot the equation or what direction it goes. I need to get rid of the pi. So I'm going to go ahead and put pi on the bottom. Because now they're going to cancel out. So whatever's on top that I need to get rid of, if degrees are on top and I need to get rid of them, I put degrees on the bottom here. If I need to get rid of the pi, I put the pi down here. What has to go above that then? It has to go degrees, and how many degrees exactly? 180. Can someone tell me why it has to be 180 over pi? Because they're both equal to each other, and if I'm multiplying by something that's equal to each other, I'm multiplying by 1. I haven't changed anything. You just need to know pi equals 180 to do these conversions. You have to know that. All right, now our pi's will cancel out. That's good. And then we're going to have 14 times 180 divided by... Hope it still works. Oh, I got your cover. Oh, whoopsie. I can't stop you guys. You guys are using calculators. So if I do 180 times 14, what do I get? 2,500 and what? 20. Pi divided by 9. And that equals... Oh, what's wrong with mine? I have a pi. Does that happen? Absolutely. I already forgot. What did you say was the answer? 280.
Wait, why is it divided by 9?
Because what basically happens here is, let's walk through. I'll write this down here. So we had 1 pi here, right? And the pi's are going to cancel. Pi divided by pi, it just cancels out. When you do multiplications with fractions, you multiply straight across.
I was doing...
Oh, you're doing cross multiplication.
Yeah.
Cross multiplication only happens if there's an equal sign between them.
Okay.
Straight up multiplication is nice because, adding, you have to have a common denominator. But multiplication with fractions are just straight across. Okay? I'm going to tell you a shortcut. What does pi equal in degrees?
180 degrees.
It equals 180 degrees. Pi equals 180 degrees. I'll say that one more time. Pi equals 180 degrees. What if you replace this pi with 180?
Is it the same?
I don't know. Try it.
You get 280.
You get 280. So you can, here's a little shortcut if you remember it.
You just multiply it
If you see pi, yep,
by 9.
we go 14 times 180 and divide it by 9, which equals 280 degrees. That's because pi equals 180, which means you can substitute it in.
It's much faster if you have a calculator.
It is much faster if you have a calculator. It comes with the same equation, but it's one extra step that you can get rid of. But if you're on the test and you forget it, then we should know that. I'm going to go through the long way on this one as well. You can go through whichever way you want to. These are your notes. But what I'm thinking is, okay, pi has to be over pi to get rid of it. So I saw the pi. I'm going to put on the bottom here. And then I know pi equals 180, so 180 degrees must go on top. Pi's cancel out. Does this one come out to an even? Kind of. 67.5? All right, cool. For degrees, we'll always use decimals. We're not going to usually use fractions. The last one is a gotcha question. Throw it out there right now. Anytime you have something wrong on your notes, and it's with degrees or radians, it's probably what happens next. When you see -6, do you see a pi attached to it? No. Radians don't have to have a pi attached to it. There's no rule that says you have to have pi attached to it. How do I know this one's radians? What was that?
No, I was just saying.
Okay.
We have to transfer to degrees.
Yep. We do have to get to degrees, but how do I know it's in radians? And maybe I'll ask a different question. How do I know it's not degrees? Oh, yeah, that's it. That is perfect. It has no degree sign. So either Mr. Pabian messed up and forgot to put a degree symbol on there, in which case you could raise your hand on a test and say, was this supposed to have a degree symbol? But if you see a -6 and there's no degree symbol, you have to know it's a radian. This is a radian because there is no degree symbol. What do I usually do if I put this on the test? I see it's kind of a gotcha question. You kind of just lose 1 point on it because you didn't realize. You could still get the points for converting it. The actual work can still suffice, but you lose that point because you didn't realize that it was a radian. And I'm not going to put a whole bunch of them on there. It's not a whole thing to drag down your grade. It's for being careful. Understanding that degrees and radians, degrees have degree symbols. Radians, we usually don't write anything after it. All right, so that means it makes it a little harder because we can't put 180 for the pi because there is no pi. This is the hardest one because you have to realize that pi has to be in the denominator. Even though it doesn't cross out, you have to realize that pi is down there because those are your radians. So realistically, in the background, I have -6 radians divided by pi radians. The radians cancel out. Pi and what are equal to each other? 180, so we're going to put 180 on top. When you are putting this in degrees, I do not want pi in your answer. I don't want 2 pi degree radians. It throws everything off. That is really confusing. So you're going to use your pi button in your calculator. Or if you don't have a pi button, you can go 3.14. You'll get close enough. So if we did -6 times 180 divided by pi, what did we come up with? I think someone said it.
343.8.
Yep. I'm going to put a negative on there. Was it 340? I already 343.8? And I put the about symbols in there. This brings up something for this class. Did I say what you needed to round to? No. And we have so many problems that might be round. I'm not going to put in every single. Sometimes I'll put it. I'll say you have to round to 3 decimal places. But if I don't put anything and you have to round, here's a good math idea. Round to the 10th place. If there's no direction on it, round to the 10th place. So if I did not put anything down, round to the 10th place. Double check the directions that I didn't put something in there. But if I don't say anything, round it to the 10th. All right, cool beans. All right, now we're going to determine which quadrant angles lie using radians. We'll get better at this. There's nice little hints to this, but we gotta brute force it today. Brute force it means I have to understand how to set up our quadrants. Now, radians start like degrees with 0. 0 radians and 0 degrees are in the same place. Full circle's 360, so half we said was 180. Not 180. What did I want to actually say? I wanted to say pi. Thank you. So if that's pi, what's straight up?
Half pi.
Half pi. We usually go pi over 2. We'll be close. We're going to have a 3. We're going to have a 3 pi.
Pi is like a half.
Yeah, 3 pi over 2. If you ever forget that, this one should be easy. Pi should be easy. Pi over 2 should be kind of easy. It's half of that pi. Now remember, this is pi over 2. Pi over 2 plus pi over 2, if you actually do that addition, equals pi. Then you could do pi plus pi over 2 equals 3 pi over 2. It's 1.5. Yeah, well, yeah. Are you good with that? All right. Now, if I ask for 7 pi over 5, hey, some of you out there might be really good at fractions. Good on you. Other of you might be weaker at fractions. Here's what I would do if I was weaker at fractions. You have a little calculator, right? All you have to do is decide this is 1/2 pi, this is 1 pi, this is 3/2 pi. You just need to figure out where 7 over 5 lays in. Now, 7 over 5, we should know that's bigger than 1 pi, right?
Yes.
Because it's 7 over 5. So we know it's either in quadrants 3 or 4. Hey, welcome. Okay, so here's my advice to you and your calculator. What's 7 divided by 5? 1.4-ish. What's 3 divided by 2? 1.5. Is 1.4 bigger or smaller than 1.5? It's smaller, so it must lie on this side. Your whole goal is to figure out, is it bigger or smaller than 1.5? So just plug in your calculator. Just do 7 divided by 5, which comes up to about 1.4. It's smaller, so we're going to end up here. It is positive, and we're going to end up here. And like I said, that 1.4 is your key. It's smaller. Maybe I'll even write that down. 7 divided by 5 equals 1.4. Nope, I wrote the wrong thing. I said it, 1.4, and this is 1.5. Do you need a pencil?
No.
Okay. All right, negative pi over 12. Now, in the future, we're going to start using coterminal angles usually with negative pi over 12. I might just add 2 pi to it, which would make a coterminal, which gives you a positive. We haven't done that yet, so let's go in the negative direction, which means I'm going to go in the opposite directions, which means I'm going to have a 0 here. I'm going to come down here and write what down here? Negative pi over 2. Yep. We got a combination of all those things. We have negative pi over 2. Now I can go negative pi. And if I have the other one written, I know that this one's going to be negative 3 pi over 2. All right, so now I'm looking at negative 1/2. I have negative 1/12. Remember, this is a 1 in front of it. Is negative 1/12 bigger than negative 1? That's a horrible way to look at it. It's smaller. It's smaller. So we're going to be in quadrant 1 because pi over 12 is really small. 1 over 12 is maybe here in that negative direction. We'd be in quadrant 4. Yep.
So when you count quadrants, it's always... So it's the same quadrant, no matter if it's...
No matter if it's positive or negative, we stay in the same. I should put that quadrant 3 on the other one. I forgot to put that one over here. That's why I wanted a negative one. The quadrants do not change depending on which way you go. It's still 1, 2, 3, 4. So that is quadrant 4.
How did you go about finding negative pi over 12?
Oh, all I did is, so we can go on our calculator and just, all I care about is the negative 1/12 because they both have pi in it, right? So I'm comparing negative 1 over 12 to 1/2. So this could be, you plug in your calculator.
Oh, okay, so that, if you like, so that would be like 6/12, you could like figure out.
Yeah. You can figure out that must be, because this is 1/12, this is 6/12, it's much more. Or a calculator gives you decimals that you know that 1 over 12 must be smaller than 1/2.
Oh, that's right,
Yeah, that's all I'm looking for. Is it smaller or bigger? We're not going too in depth with it. It's just, is it bigger or is it smaller? All right, our last one. Where are we done at? 10:50? Okay. 2.25. How do I know that's a radian? No degree symbol. There is no degree symbol, so it must be radians. Now, 2.25 doesn't have pi in it, right? So here's my advice to you when you draw your unit circle. So we usually have, what, pi over 2. We have pi, and we have our 3 pi over 2. Now, all of these have pi in it. My thing does not have pi in it. Well, let's get rid of pi's. And that doesn't mean cross them out. I mean, you can just put them in your calculator. Or in other words, pi equals 3.14, right? About? Yes. That's close enough. I should probably put an about symbol in there. So rather than putting pi in there, I'm going to put that's about 3.14. Oh, 2.25 is smaller than that. But I need to check. It could be in quadrant 1. It's probably in this quadrant because it's pretty close to it. But maybe we'll do our pi over 2 divided by, or pi divided by 2. What would be pi divided by 2? Yeah, 1.6. What did I have down? Well, 1.57. I did it to hundredths. But yeah, we could go about 1.6. 2.25 is definitely bigger than that. So it's definitely going to be in this quadrant somewhere. So that'd be quadrant 2. So if my radians don't have pi in it, I'll get rid of pi from my key points. Does that make... We're okay with that? Are we sure? Radians can be really difficult.
Sounds good.
We use them for a while. They'll get a lot easier as we use them. You've never used them before? Oh no. What was it? Oh, yeah, I absolutely can. Yeah, that's what. All right, let's finish up. Coterminal angles. Coterminal angles work just like degrees. However, degrees I spin 360. For radians I spin, I forget, 2 pi. Because I'm going to radians. Yeah. So instead, anytime we say 360 and I say radians, you need to think 2 pi. If I say 180 in degrees, you need to think pi in radians. So when we're looking for coterminal angles in radians, I'm looking for things that are 2 pi away from each other. Just like 360, but now it's 2 pi away from each other. So the equation is going to look a lot the same. We're going to say basically the measure of one of the angles, we'll call beta, equals the measure of our alpha. Plus, remember the other side we had k times 360. We're going to have k times 2 pi. Once again, I don't think that's the easiest way to think about this. The easiest way to think about this is adding or subtracting 2 pi over and over and over. Adding or subtracting 2 pi over and over. Just like with 360, except this time we're doing 2 pi over and over. So the next thing says find 2 positive. I think I switched it to just 1 negative. That's coterminal with pi over 6. So if we go back to our degrees, somewhere back here. No, one slide less. We just added 360 or we subtracted 360. For radians, instead of 360, I'm thinking 180, I'm thinking 360, I'm thinking 180, I'm thinking. Okay, so we're thinking coterminal, which means 360. So for radians, I'm thinking 2 pi. So if I want something coterminal to pi over 6 and it's positive, I'm just going to go, let's take pi over 6 and add 2 pi to it. Here's where you guys are going to hate radians. When you add fractions, you need a common denominator. So I need to change this just a little bit. Pi over 6 plus, how can I rewrite 2 pi? In other words, how can I rewrite 2 to have a denominator of 6? Say it. 2 pi over 1.
12 pi over 6?
12 pi. Let's check. We need a common denominator of 6, right? We know we need to have pi in it. It still has to equal 2, right? What has to go here divided by 6 to still equal that 2?
Oh,
It's got to be the 12. So the 12 was correct. Here's a little advice to you. If it's just a whole number, you're just multiplying the top and bottom by 6. So whatever you need to multiply the denominator by, so I'm picturing 2 over 1. I multiply that 1 by 6, which means I multiply the 2 by 6 to get me 12, which means I'm going to have 13 pi over 6. It says 2 positive, correct? So we need to then take that, we have to add 2 pi again. So we'll have 13 pi over 6 plus 2 pi. What do we write 2 pi as so it has a 6 as a denominator? Yep. That's why take that first one, take your time getting that right because you're going to reuse it. So we're going to add 12 pi over 6. And that's going to equal 25 pi over 6. 2 positive, 1 negative. How do I make a negative angle? Yeah. What if that didn't make it negative? What if I subtracted 2 pi from it and it didn't make it negative?
Do it again.
You would keep going until it's negative. If I ask for a negative value, you keep subtracting 2 pi until it's negative. Now, you could shortcut this a little bit. I'm going to write the full thing, but we know pi over 6 minus 2 pi. We're going to rewrite 2 pi as, I forgot already. 12 pi over 6. And that's going to be a negative 11 pi over 6. What do all three of those angles have in common? What is the term if they're all just adding or subtracting 2 pi? Coterminal is correct.